In this next example, this gets a little trickier. We have x squared plus 1 over x minus 4 minus 3x plus 5 over x minus 4. Okay, when you see subtraction in general, you need to be very, very careful. Because, well, let's write this out. We are going to take the first numerator, x squared plus 1, and subtract the second numerator, 3x plus 5, and put that over that common denominator. But the way I wrote this, I didn't take the first numerator and subtract the second numerator. The way this is written, all I'm subtracting is 3x. I'm actually adding the 5. So I need parentheses here. And now what we have is x squared plus 1. Distribute that minus, and we get negative 3x minus 5 over x minus 4. Combine any like terms, so we have x squared minus 3x, and we can combine the positive 1 and the negative 5, and that's negative 4 over x minus 4. Now we're not done, we haven't simplified, but I want to show you another way to do this. And what I like to do is change subtraction whenever we have more than one term in the numerator following. Change this to addition, but then we have to change every sign in this numerator, which really is the same as distributing the negative here. And so now I'm ready to add my numerators. So we get x squared plus 1 plus negative 3x minus 5 over x minus 4. And that leaves us with x squared minus 3x. Combining like terms, we have 1 minus 5, which is negative 4. And that's x minus 4. So these are two different ways to go about it. I find that students perform better when they go this route, however. In either case, now we are ready to factor and simplify. So we have a trinomial in the numerator. Leading coefficient is 1, so we get x and x. Last term is negative, so we get opposite signs. And we want factors of 4 whose difference is 3. Well, 4 times 1 is 4. The difference is 3. And of course, the larger number gets the middle sign. So 4 goes here, 1 goes here. Over x minus 4. And now we look for common factors, and we can see that we have x minus 4, and we are left with x plus 1 over 1, which is just x plus 1. In our next example, we have 4a squared over 3a minus 1 minus a squared plus a over 3a minus 1. So try to go ahead of me and see if you can deal with this subtraction. That should definitely raise a red flag right away. You know you have things to do. I don't know why that disappeared. So we're going to change that to addition and change every sign in the numerator following. And so we are left with 4a squared, and now we're going to add this numerator, so it's minus a squared minus a over that common denominator. Well, 4a squared minus a squared is just 3a squared. And now we're ready to simplify. The numerator has two terms. We look for a GCF and we find we have a common factor of a. So we factor it out and we're left with 3a minus 1. And now we cancel our common factors and the whole thing winds up to equal, well, those become 1s, 1a over 1. So that's just a. In this example, we have 3x plus 3x squared over x minus x squared minus x over x. So we see that subtraction, and right away we change the subtraction to addition and change all the signs in the following numerator. And now we're ready to add these expressions. Okay, so in the first numerator, I'm going to reorder those because I really don't like that. We have 3x squared plus 3x. In the second numerator, we have minus x squared plus x, all over x. Combining like terms, 3x squared minus x squared gives us 2x squared. And then 3x plus x gives us 4x over x. And now we're ready to simplify. The numerator has two terms, and we see a GCF of 2x. And we're left with x plus 2 over x. Well, we have a common factor of x, and we are left with just 2 times x plus 2. Now, in this problem, actually, both expressions could have been simplified in the first place. Let's take a look at that. I have a common factor of x in this expression. So if I factor that out, I'm left with 3 plus, oh, actually I have a common factor of 3x. So I'm left with 1 plus x. And then we had minus x squared minus x over x. So we had a common factor there of x, and that leaves us with x minus 1 over x. Happens that both of these could be simplified. Cancel the x's. Cancel, whoops, wrong spot. This particular software does not allow you to see your pen very well. So we're left with 3 times 1 plus x, so that's 3 plus 3x, minus, be careful about that, x minus 1. So now, simplifying, we have 3 plus 3x. Now we want to distribute that negative, so we have minus x, and make sure you change that sign as well, so that's plus 1. Combining like terms, well, 3x minus x is 2x, and 3 plus 1 is 4. Now, I actually shouldn't have left this other one in factored form here. We have 2x plus 4. So you can see we wound up with the same result either way. This is dangerous ground, though. And the reason is, if you have something with a common denominator, two expressions with a common denominator already, like we had here, if you were able to simplify one of them and not the other, you'd be stuck with something without a common denominator. And then you get all tangled up. So if you already have a common denominator, usually your best bet is just leave it alone.